So now you've gone through these practice questions. Let's talk about them a bit. The first one basically talks about the expansion joints on the bridge. And so you have these interpenetrating fingers. The problem being that if you, because the parts of the bridge tend to expand with temperature, if you don't have these expansion joints, then you tend to have huge problems. And again, the idea is that if you have a bar, and I'll vastly over-exaggerate this, and so this basically has a length of L naught at some particular temperature. So let's assume that this is 0 degrees C. If you raise the temperature, and certainly is not this large, the idea is that if you have L naught is the original length, then delta L is the length that it expands. And so what you end up getting is that the linear expansion basically is just the change at some particular temperature, some higher temperature. And so let's call this T final and T initial. That this is just linear with the temperature. You have some initial temperature, some final temperature. And the degree of expansion depends on the length of the material that you have. Now the idea is that if you had a bridge which had essentially just butted up against each other, each one will expand, and so what will happen is the bridge will buckle because as they get longer, there's nothing to take up the difference, and so the bridge will tend to buckle as it basically pushes against each other. This is why essentially for these you always put these expansion joints, between each two sections of the bridge. You always find them. And so the idea is that this gap allows you, as the rate of temperature goes, the bridge lengths get longer, and so the gap becomes smaller. So the idea is that these gaps become farther apart in the coldest day of the year and closer together on the hottest day of the year. And so it's actually C that makes the sense. Because again, the bridges expand with temperature. And if you have a very long bridge length, then essentially the expansion can be pretty substantial. You'll notice that this will at least allow you to get probably an inch or two of expansion. The second one really talks about the linear expansion. It says the picture shows an expansion joint at the midpoint of a bridge over the Ohio River. On a day when it is 0 degrees C, the air gap is measured to be 3 centimeters. And when it's 20 degrees C, the air gap is measured to be 1 centimeter. So in other words, at 20 degrees C, it's basically the bridges have expanded, and so there's less airspace between each joint. So what will happen on the air gap on a cold day when it's minus 10 degrees C? And since for every 10 degrees C, effectively the gap decreased by a centimeter, because it went from 3 centimeters to 1 centimeter, the idea is if it goes to minus 10, it will only get about half that gap, and so it'll go from 3 centimeters to 4 centimeters. And so the appropriate answer actually is B, so that when it's colder, it will actually go to 4 centimeters. At 10 degrees C, it would be 2 centimeters. At 20 degrees C, it would be 1 centimeter. The last one is, suppose that you have a steel plate which has a 4-inch diameter hole through it. If you heat the plate to 100 degrees C, the hole gets smaller, gets bigger, stays the same size. This plate is blue, and the hole is basically that white circle inside there. And so the question is, because as you raise the temperature, you know that the plate will expand, what happens to the hole? And the idea is that frequently what many people will say is that this plate gets larger. Essentially, the hole gets smaller because it will expand essentially closer towards the center. But actually, the entire plate gets larger. And you can see this essentially if you were to look essentially at, say, all the atoms on the ring, on the inner surface of that hole. If they want to get closer together, and so if you make the hole smaller, actually the atoms get even closer together, right? And if you make the hole larger, then the space between the atoms gets farther apart. And so this is the best example I know of as to why the hole gets bigger as you raise the temperature. And you know this actually because frequently if you have a lid that's stuck on a jar, sometimes the most effective way to get the lid unstuck is to put hot water over the metal lid. Metal tends to expand more than glass, and so if you make the lid hotter, then essentially it will tend to expand more, and so frequently that will cause it to unstuck, basically become unstuck. So this is the end of basically this. After this, we're going to talk about the ideal gas law.